Okay, let's get into this one. It says that, I move my camera every time and then I sit down in a different spot and it like I might be OCD, but it's never centered. Anyways, the owners of a circus are planning a new act. They want to have a trapeze artist catch another acrobat in midair as a second performer comes into the main tent on a zip line. If the path of the trapeze can be modeled by the parabola y equals 1/4 x squared plus 16, and the path of the zip line can be modeled by y equals 2x plus 12, at what point can the trapeze artist grab the second acrobat? Okay, so the first thing, does everybody have a calculator? The first thing we could do is, we know that for a system of equations, we can simply graph these and find the intersections. All right, so let's do that. So I'm gonna pull up my handy dandy calculator. All right. Oops. Now the reason I jumped right into my TI calculators, notice that both equations are already solved for y. So that's pretty good. Now, can we put fractions in these calculators? Yes. How do I do that? Can you guys remind me?
You go to the math setting and you scroll over to the fractions.
Yep. Go to math. Yep. And which option?
The first one.
The first one. Very good. And so then I'm going to put in 1/4. Remember to use the cursor to move over to the right. X squared, right, plus 16. So that's the first equation. Now for the second equation, I got to move this over here. I think it's just 2x plus 12. Now, I'm going to tell you this. You should know it, but maybe you didn't think of this. What's the y-intercept on y1? 16. What's the y-intercept on y2? 12. So my graph has to keep that in mind, right? So what I'm going to do, and this x represents time, I think. I got to reread the question. So I'm going to go to window, right? And I'm going to, it's got to start at 0, I suspect, right? And also, well, let me think this through. Let's do the -10 just in case, because it's the quadratic. Well, yeah, it doesn't shift much. So yeah. But my y values are important because I know it's got to be above 12. So I'm going to put my minimum at 10, and I'm going to put my max at 30 just in case, right? Because my y-intercept is going to be that quadratic. That quadratic is, it might, and it might even be higher. So let me put this at 50. I don't know how high this thing is. So my quadratic is going to have a y-intercept of 16, and that has to cross the linear function that has a y-intercept of 12. So now let's hit graph. Bloop. Touches one time. It's tangent to the curve. Okay, so I'm going to take a screenshot of that. Actually, let's find the intersection, and I'll take a screenshot of the whole thing. So how do I, Mr. Adams has forgotten how to do this. How do I find the intersection? Can somebody help me? Trace? Or second trace? Second trace. Very good, because we want that calculate menu. And then what option? What's funny, you guys can't see it on the camera. Everybody is just diligently trying to do it on their own. So you're gonna, yeah, it's intersect. So then what I do is I move the cursor over to where I think it's intersecting, right? It'll say first curve. Now what that means is I'm trying to identify where the blue line is crossing the red line. Now I don't know. When I hit enter, it'll say second curve. Same thing. I'm trying to figure out where the red line crosses. I don't know. And then the third one, I can move the cursor anywhere on the screen But if you get it close enough on the first go around, and it's kind of hard to see, but it looks like x equals 4 maybe, right? The calculator guesses. It does like some fancy math, but I think it's 4. I'm guessing, but I think it's 4. So I'm going to leave that in there. You could redo it and see if you get a better answer, but we're going to do some math and see. So there's that one. You got x equals 5? Okay, well, we're going to do the math and check it out. So the other thing we could do is we could go to the table, right? So if I hit second graph and I go to the table, I think it's 4. What do you notice at 4? The y1 and the y2 are the same. So it's probably 4. Now, if you're getting 5, I'd double check that. Make sure you entered the equations properly. What do you get at 5?
Actually, just mistake it by accident.
Yeah, that's okay. So that's the thing we're looking for. So we think 4 is the answer. So now what do you think we're going to do? You don't need to write the whole thing down. Just say when x equals 4, y1 equals 20. When x equals 4, y, you just this portion. You just need to, you could skip it. I would write down this and then the last row at the bottom here. I'd write this down. Those are the two things I would write down. You don't need to write the other stuff. Doesn't matter. Okay. All right. So now let's do the algebra. They're both already set equal to y. Sweet. So you know what that means, right? We can just set them equal to each other. So let me grab my handy dandy little tablet thing. So I'm going to say that 2x plus 12, which is equal to y. See, because this is equal to y and this is equal to y, and we're looking where they equal y together, where they have the same y value. So I'm going to say 2x plus 12 is equal to 1/4 x squared plus 16. Well, that's cool, but what is it that we don't like about this problem? Huh? What's that? Well, x's are on both sides, but there's something else that we really don't like. Well, it's not set to 0. Oh, man, this is all good stuff. Well, I was going to say the fraction, but I forget you guys are scholarly mathematicians. So let's get rid of the fraction. Huh? No, let's do it this way. So what's 4 times 2x? 8x. What's 4 times 12? 48. What's 1/4 times 4? Kinda. What's 1/4 of 4? 1. What's 1x squared? X squared, right? And then what's 4 times 16? 64. Yep. So I don't know if the microphone picked this up, but I said, what is it that we don't like about this? And there were lots of things that were shouted out. The x's aren't on the same side. Good call. It's not set equal to 0. Remember, we have a quadratic, right? So this is probably going to look like ax squared plus bx plus c equals 0. I think what you guys were alluding to, right? So that's how we solve it. So let's start that process. I'm going to subtract 8x from this side. I'm also going to subtract 48 from this side. Remember, whatever you do on one side, you have to do to the other. So these cancel, and I've got 0 over here. And over here, I have x squared. Is x squared the same as 8x? No, they're different. They're not like terms, so I just leave them separate. What about 64 and 48? What are those? Those are both constants, so I can just straight up subtract them, right? So what's 64 minus 48? 16. Somebody double check that on the calculator and make sure. Okay. So now I can solve. Now how do I factor this? What do I do to factor this? Does anybody remember? I want it to look like x plus or minus a number times x plus or minus a number? You could. There's a couple ways to do this. Let's just do the guess and check method. So I know that there are two things that when I multiply them, they're going to give me this stuff here, right? So for guess and check, I put the first term in and I put the last term in. Well, to get x squared, I have to have x times x. Here's the other thing. I have to have two numbers that when I multiply them, they give me 16. But when I add them up, they have to equal this middle term of negative 8. Yeah. So if I put a negative 4 here times a negative 4 here, what's negative 4 times negative 4? Positive 16. What's negative 4 times x? Negative 4x. What's negative 4 times x? Negative 4x. Okay, this is an x. It doesn't look like it. So what's negative 4? So when I do the math on this, I get x squared minus 4x minus 4x plus 16. If I combine like terms, these are the like terms, I get negative 8x. Right? So what does that mean? That means that this is x minus 4 times x minus 4. And all of that is equal to 0. Remember that 0 times 0 equals 0. Therefore, x minus 4 has to be set equal to 0. And x minus 4 has to be set equal to 0. It's the same thing. So I add 4 to both sides. And I get x equals 4. This is going to sound ridiculous, but we do the same thing over here. And that is x equals 4. Now you might be thinking to yourself, Mr. Adams, that was silly. Why did you do it that way? Well, the solution is x equals 4. I'm going to give you some fancy math term. This is called multiplicity 2. That means so when you have a linear equation, when you have an intersection, how do I word this? You can have the same solution more than once. Since it's a quadratic, you can have up to 2 real solutions, right? And so if we follow the math, I get the same answer twice, which is 4. We say that the solution is 4 multiplicity 2. That gives the mathematician an idea that x equals 4 and x equals 4 is part of the solution process, which will lead you to a quadratic, blah, 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 blah. Okay, any questions on that? Does that make sense? I think the thing that we need to work on a little bit more is factoring quadratics. You can always use the quadratic formula. And also, I put a video, maybe I should put a link in Schoology. You can program your calculators. Did I go over that with you guys in class? Program it to do the quadratic formula? Okay. Well, I don't know if we'll have time today, but maybe I'll show you the video. Anyways, any questions on this one? No. I'll leave that up there for just